our next group to deal with, our next functional group is this amino group. So we're going to start talking about amines. We've actually already seen at least one amine, as you'll see here in a second. But anytime I have this NH2 attached to anything, so I could have any carbon chain, and then have this amino group attached to it, that is an amine. As long as you see a nitrogen, it's an amine. Right? So there's going to be a lot of different compounds that we could discuss in the future that have a nitrogen in them. But if you see that NH2 specifically, this is an amino group, right? So it wouldn't matter if it looked like this version, or if maybe there was a ring with that NH2 attached to it. Or maybe it's a special kind of ring, a benzene ring with an NH2 attached to it. In which case it's not called benzene anymore, it's called aniline, and we already know that, right? That's the one that you should recognize. But that amino functional group, right, that nitrogen is always part of an amine. Now that being said, there are a lot of different kinds of amines, because that amino group is actually just primary amine, right? Anytime you have that NH2, anytime you have that nitrogen connected to one carbon, it's primary, right? So all the examples on this last slide that I gave you are primary amines. And that's confusing because all of these looks that I gave you are somewhat secondary if we were talking about alcohols, or that aniline down here again would actually be more like a tertiary if it was an alcohol. So there's different rules for classifying amines than there was for alcohols than we use for alcohols. So just be careful, right? They're completely different things. Understand what primary, secondary, and tertiary mean for alcohols, but also understand what primary, secondary, tertiary, and even quaternary, a new thing, mean for amines. So remember, nitrogen can make 3 bonds, always, right? So the basic idea is if it's connected to 1 carbon, it's a primary, right? If it's connected to 2 carbons, it's secondary. If it's connected to 3 carbons, it's tertiary, right? In order to connect to 1 more carbon, I'd have to lose an electron, which would actually make this nitrogen positively charged, right? If I wanted to make 1 more bond to 1 more carbon to make it quaternary, which is why there's always a charge associated with that quaternary ammonium salt. So there's a charge right here in your notes, right? That's what that means, right? In order for nitrogen to make a 4th bond, it has to be charged. So I have primary, secondary, tertiary, quaternary. Again, I already drew a couple primaries for you, but a secondary amine would look something like this maybe. But I have to be careful because nitrogen always makes 3 bonds. So that's why it's actually going to matter how many hydrogens you have attached to this nitrogen. So I can draw this secondary amine like this, and it'd be a little bit more accurate because I'm actually telling you what's going on, right? If I gain or lose hydrogens on a nitrogen, it actually changes the charge of that nitrogen. So it's important that I list how many hydrogens are there every time. Remember these 2 methyl groups that are attached to this nitrogen? They have hydrogens too. I just don't have to show those because we know that carbon's always going to have 4 bonds. It doesn't have 5 bonds ever, or 2 bonds, right? So nitrogen being unique, being not like carbon, you do actually have to tell me how many hydrogens are there every time. So I draw it like that. Or, right, that same secondary, I could just put an NH and have those 2 methyl groups hanging off. And it'd mean the same thing, right? Tertiary, once that nitrogen has 3 bonds on it, maybe 3 different R groups, right, a methyl, an ethyl, and isopropyl on it, right, this one would be tertiary, whereas these 2 are secondary. We could label those appropriately. But this nitrogen will not have a hydrogen on it because because if it did, that would change the charge. So tertiary, you just have the nitrogen, no hydrogen. Secondary, you have a nitrogen with 2 carbons bonded to it, but 1 hydrogen. And then again, going back to those primary examples, right, they always have 2 hydrogens. That's that amino group that we were talking about before. Right? This is technically no longer an amino group when I'm looking at this nitrogen in this secondary amine. It's still an amine, it's just not an amino group anymore. I can't name it like a branch. So I'll have different kinds of names for secondary and tertiary amines. Right? And then finally a quaternary amine. Again, once I have a nitrogen that's bonded to 4 different carbons, right? Maybe they're all methyls. Right? This nitrogen would also have to have a charge, and that's important to understand. Right? So it's usually a salt, it says, which just means that, okay, this positively charged center here would probably be attracted to some other negatively charged ion, like a chloride ion. So you can have a salt, that's what that's saying. Right? Positive and negative to make some kind of crystal. But again, this is quaternary, which we'll just write 4 degree for that. Understand the difference though. There's primary, there's secondary, there's tertiary, and quaternary. But again, be careful, because last chapter we would have considered this situation here, or excuse me, earlier this chapter, if this was an alcohol, we would have been calling this one secondary, but it's a different rule now. So understand the difference. Aside from classes, right, some amines are really, really important in living things. Just to give you a few examples here, right, acetylcholine is a neurotransmitter, right, used in your brain. And that molecule up here is an amine because it's got this nitrogen in here, right? You can see the nitrogen. You also can see that that nitrogen is attached to 4 different carbons, which is what makes it positively charged, which is what makes it quaternary, right? It's a specific class of amines that I can still see, I can still recognize. I'm just not going to know how to name this thing because it's too complicated. It has other functional groups in it, right? So I do have a few other things going on here that we haven't even talked about yet. Right? It kind of looks like an ether. It kind of looks like there's a ketone in there, right? But when you combine those 2 things, that's actually a whole new functional group. That's actually going to be called something different later. So this is a complicated molecule, but again, I just want to be able to point out a few specific examples that are amines that are in living things. Right? Acetylcholine is a quaternary ammonium salt. Right? Whereas if I look at caffeine, morphine, right? This is the molecule for caffeine. You don't have to have these in your notes. You don't have to draw them in. But it's just nice to see them at some point or another. You can see that there's actually 4 different nitrogens in that caffeine molecule. And all 4 of those nitrogens are actually tertiary, if you can tell. They don't have hydrogens on them. They have 3 carbons bonded to each one. This one's a little bit different than the rest because it's got a double bond and a single bond to attach to 3 carbons, although it's technically 2 carbons. But it's still tertiary, right? Because that nitrogen has bonds to 3 carbons. It just bonds to the same carbon twice. Whereas my morphine over here, that you've probably heard of, and that's the other thing that we need to pick up on. Anytime you see that ending, INE, right? Anytime you hear that, right? So caffeine, morphine, acetylcholine, right? It's spelled a little bit differently, but same idea. If it sounds like that at the end, it probably has a nitrogen in it. So you've probably heard of other things that have nitrogens in them, like say nicotine. Or if you go back to biology, when we were talking about nitrogenous bases specifically, we were talking about the nitrogenous bases found in your DNA. Adenine, thymine, guanine, cytosine, right? All ending with ene. So They definitely have nitrogens in them. This amine down here is also tertiary. You have to understand that this Me is just a methyl group. Why they didn't want to write it that way? Again, there's a lot of different shorthands for organic chemistry, and you just have to get used to it. But that is a carbon there. That's a methyl group that's attached there. So this nitrogen is also tertiary. It's connected to 3 different carbons. You can also see in that morphine, it's kind of a complicated structure in the fact that it's 3D. Right? It can't be drawn 2D. Right? There's a strange ring structure here, a 6-carbon ring, another 6-carbon ring, and then a third 6-carbon ring that are all kind of attached to each other and create this 3D look. You can't draw this in 2D. So, again, these are complicated examples of amines. They're not ones that we're going to be able to use in this chapter and name in this chapter, but you can see how that functional group can be important